this is true. So we see that from these two examples, it becomes apparent that there is no logical relationship between an implication and its converse. Given the implication is true, the converse may be true or may be false. There is no logical relationship, but there is a very nice logical relationship between an implication and its contrapositive, namely that they are logically equivalent. If this is true, this has to be true. If this is true, this has to be true. Okay, in fact, that is one of the laws of logic that we are going to state and prove. So now that we have, okay, let me wrap this thing off first. Now that we have, how many constructs we have come across so far? First, we had conjunction of two statements and, then we had disjunction of two statements, or then we had negation of a single statement, right? Then we had logical equivalence of two statements, x if and only if y. And using these four, we have already stated and proved some of the laws of mathematical logic. Now that we have this new construct, implication, using this we can state some more laws of logic and we are going to prove them. So let's go for that now. 6 or 5 or 6, I think we have. Anyway, I'm going to number once again. In these statements, it is assumed that x, y, z or z, whatever you may call it, these are mathematical statements, or these are in general statements. Okay, I'm not going to write that or mention that explicitly. I'm just going to give you the laws. So the first law is law of, it's not the first law, of course, it's the first law that I am writing it now in this list. Law of addition. Or laws of addition, I may write, although it's a single law, you will understand well. Suppose you have a statement x, then you may bring in another statement using disjunction. X implies x or y. Similarly, y implies x or y. You are, in this case, you are bringing in x, so you are adding one new statement. It may not be a new statement, it may be y itself, that is, you are adding statement. So this is law of addition. The second one is laws of simplification. It's just the opposite. Here we start with a conjunction. Unlike the previous case, we now have conjunction, not disjunction. Okay, this is a common mistake to confuse between these two. When we have addition, we have disjunction. When we have simplification, we have conjunction. So we have a conjunction. From that, we can simplify and remove one of the statements. Any one of them. X and y implies x. X and y implies y. Okay, so we have simplified. From conjunction, we have reduced to a simpler statement, and in this case we have added one more. From a single statement we have got disjunction. And finally, we have that relationship between an implication and its contrapositive. So naturally it's called law of contrapositive. And I have already told you what it means. An implication, this is an implication and its contrapositive. Negation of y implies negation of x. These two implications are logically equivalent. They are one and the same thing logically. They mean the same thing. Either both of them are true or both of them are false, recalling the meaning of this. Okay. Now we are going to prove one of these two and this. So I choose to prove the first one. The second one I leave it to you, law of simplification. Right. So now we want to prove laws of addition.